Hello students, welcome to my YouTube channel. Today I'm going to take the chapter Introduction to Trigonometry. Okay. So now what is trigonometry as such? So let's see the definition. So the word trigonometry is derived from the Greek words tri meaning three, gon means meaning sides, and a metron, it means measure. In fact, trigonometry is a study of relationship between the sides and angles of a triangle. Okay, I repeat. So trigonometry, it is derived from the Greek words tri, gon, and metron. So tri means three, and gon means sides, and metron means measure. So in trigonometry, you're going to study the relationship between the sides and angles of a triangle. Okay, and so now where it is applied now, where do you use this trigonometry? Let's try to see here. So we have the applications of trigonometry. So the first point I want to discuss is early astronomers used it to find out the distances of the stars and planets from the Earth. So you can see this. Let me show you the pictures here. So like this, so they were the early astronomers. You can see in this picture. So these early astronomers, they were using this the knowledge of trigonometry to find the distance of the stars and planets from the Earth. Okay. The next one. And the technologically advanced methods used in engineering and physical sciences are based on trigonometrical concepts. Okay, so now we have one picture also for this. Okay, so now this comes in physics. Okay, so here we use the knowledge of trigonometry. So we come across the refractive index sin I by sin R. So there you are going to use this trigonometry. Okay. So technologically advanced methods used in engineering and physical sciences are based on trigonometrical concepts. The next one is it can be used to find the height of a tall tower or a tall building's summit of a hill. Okay. So let me put some picture for this. See how to calculate tower building height. Okay. So now here you're going to learn how to find the approximate height of the tower without actual measurement. Okay, using the knowledge of trigonometry. Okay. And then so here we have the one more picture. So here the person is trying to find the height of the summit of the hill. Okay. So here also we can use the knowledge of trigonometry to find the height of the hill. And the next thing, it can be used to find distance between the two ships sailing on the sea. Okay. So now we have the two ships here, A and B, and here the person is standing on the lighthouse. Okay. So and he's watching those two ships. Okay, and he wants to find a distance between these two ships. So this can be found out using the knowledge of trigonometry. Okay, and then it can be used to find the distance between two balloons flying the air or the altitude at which the balloons are flying. Okay, so now here we have this. Okay, I have the two balloons which are flying in the air, and I want to find a distance between I want to find a position between these two balloons. Okay, that can be found out using the knowledge of trigonometry. All these things you are going to learn under the applications of trigonometry. Okay, children. Then In this trigonometry, what's the speciality is that we are going to consider one special triangle here. That triangle is right angle triangle. Okay. So what is right angle triangle? So let us see what is a right angle triangle. So what is a right angle triangle? A triangle in which one of the angles is 90 degree is called a right angle triangle. Okay. So here one of the angle will be equal to 90 degree. Okay. So let me give the figure for this. So you have this the triangle ABC wherein the angle B is 90 degree. Okay. And then here there are some important concepts that I want to introduce. So in this particular figure, you have triangle ABC. Okay. It's a right angle triangle in which angle B is equal to 90 degree. And here angle C equals to theta. Okay. It's called the angle of consideration. So here we have the angle C, which is nothing but the theta. Okay. And then it's also nothing but I can also call it as reference angle. And here the side opposite to theta is called the opposite side. So that means, which is opposite to theta means here from for the angle C we can call it as theta, and you can clearly see this AB is the opposite side. Okay, and then the side adjacent to theta is called the adjacent side. So now, which is the adjacent side here? It is BC is the adjacent side. So we have BC as the adjacent side, and then the side opposite to angle 90 degree is called the hypotenuse. So in this figure, AC is the hypotenuse. And in fact, it is the longest side in a right angle triangle. So for any right angle triangle, the hypotenuse is the longest side. Okay. And now here, remember this. Okay, so the side opposite to 90 degree. So how do you denote 90 degree? Usually we are going to indicate with a box. So you can see here at the corner of the C, near that B, we have put a box. So that box indicates 90 degree. Okay, children. Next, next question, why we should use this right angle triangle for calculating trigonometric ratio is the next question that arises in our mind. Okay. So why a right angle triangle is considered for calculating trigonometric ratio? So there should be some reason, right? So now here, there's one special quality of a right angle triangle. Since a right angle triangle always satisfies Pythagoras theorem, it is considered for calculating trigonometric ratios. Okay, so that is one beauty of this particular triangle. So what is this Pythagoras theorem that we are going to study in our next question? Okay. So what is Pythagoras theorem first of all? So I've learned about in your previous classes, but I want to brush up that. So what is Pythagoras theorem? It states that in a right angle triangle, the square on the hypotenuse is equal to the sum of the squares of the remaining two sides. Okay. Now what do you mean by that? Let me take one figure for this and try to explain you. Now here we have this Pythagoras theorem. We have got a right angle triangle, and as I told you earlier, this C is the one with the hypotenuse. The side opposite to 90 degrees is the hypotenuse. Okay, and I have marked this the side C with the red color, so you can see the red font here, and then we have A the blue with the blue font, and then we have the B with the green font. Okay, so now if I want to find out this hypotenuse, it will be nothing but this this hypotenuse actually hypotenuse square will be equal to the sum of the squares of the remaining two sides, that is the a square plus b square. Okay, so now okay, so now what is this actually? So here we come across what is called Pythagorean triplets. Okay, this one what you learned, what you're seeing is that this c square equals a square plus b square is also called as Pythagorean triplets. So what are Pythagorean triplets? So they are the sets of three integers that satisfy Pythagoras theorem. For example, let me take one example for this. See, for example, we have 3, 4, 5. It's an example of Python triplet. That means 3 square plus 4 square. What is 3 square? 3 square is 9, 4 square is 16, 9 plus 16 is 25. So 25 equals to 5 square, right? So that means if you have, you can construct a right angle triangle with these three measurements. So 3, 4, 5. So you will get a right angle triangle with these measurements 3, 4, and 5. Got it, children? Now that is, I can say that. So here we have like this. So 3 square plus 4 square. Or I can write it as 3 square plus 4 square equals to 5 square. Okay. Now we have some more examples. I want to just show you. So these are the some more examples. So we have 3, 4, 5. Okay, that is 3 square plus 4 square plus equals to 5 square. That is already said. And then we have 5, 12, 13. So even here also, this is also a Python triplet because 5 square is 25 and 12 square is 144. If you add up 25 and 144, you get it as 169. Okay. And then we have 7, 24, 25. So 7 square plus 24 square will give you 25 square. That is 7 square is 49, 24 square is 576. If you add it up together, you get it as 625. See, 625 and is nothing but 25 square. So similarly, we have all these triplets. So there are infinite number of Python triplets. Okay. So what is this Python triplets? Using this, you can actually write a right angle triangle with these sides. Okay. So 7, 24, 25 will be one triangle. Okay. One right angle triangle. 8, 15, 17, you can draw one more triangle like that. Okay. Next, coming to our main part, it is trigonometric ratios. Okay. So let us try to learn what is trigonometric ratios. So in trigonometry, there are six functions. So there are six functions of an angle commonly used in trigonometry. And their names and abbreviations are sine, that is sin. So we are going to use it as sin. So you should always read it as sine. Okay, do not read it as sin. You should read it as sine. And then cosine, so we write it as cos. Okay, and then we have tangent, tan, and then cosecant, cosec. Okay, and then some people, even they in computers and all, they write it as csc. Okay, even in textbooks also we have seen written as csc also. Okay, for cosecant theta. And then we have secant, so sec, and then cotangent we have cot. Okay, so totally there are six trigonometric functions that you are going to discuss now. So what is use of this trigonometric ratios as such? See, these ratios help us to find the missing angles and the missing sides of a triangle. So basically, they help us to find the missing angles and missing sides of a triangle. So when you take up problems, you'll be trying to, you'll understand how these are used, how these concepts are used. Then I come to the next part. Now here we have the triangle. Okay, so ABC, and here AC is the hypotenuse, and I call this AB. Okay, this is the adjacent sides here. The side or adjacent to the angle theta will be called as adjacent side, and BC, the side opposite to theta, will be called as the as the opposite side. So BC is the opposite side, AC is the hypotenuse, AB is the adjacent side. Okay. Now, the first ratio that we define in trigonometry is sine theta. So, what is the sine theta? So, we have like this, see, sine theta, which is nothing but opposite by hypotenuse. Okay. So, that is the first ratio we have opposite by. So, this is an opposite by the hypotenuse. Okay. And then we have the cos theta, which is nothing but adjacent by hypotenuse. Okay, that is the cos theta. So adjacent side by the hypotenuse. And then we have tan theta, which is nothing but opposite by adjacent. Okay. So these are the first three ratios. So what is sine theta, which is opposite by hypotenuse, cos theta is adjacent by hypotenuse, and tan theta is opposite by adjacent. Okay, children. Then I have the remaining three ratios. Let me explain you. Okay. So one is, that is cosecant theta. So cosecant theta is nothing but hypotenuse by opposite. So now how do you remember this? See, if you look at this sine theta and cosecant theta, they are inverse of each other. What is inverse? Inverse means, suppose here you are opposite by hypotenuse, right? So the numerator we have the opposite and the denominator we have hypotenuse. But in case of cosecant theta, it will be the reverse of it. That means in the numerator, you have the hypotenuse, whereas in the denominator, we have the opposite. Okay. Then, similarly, now we have the secant theta. So, secant theta is also same way happens. So, here we have adjacent by hypotenuse, but here in the secant theta, it will be hypotenuse by adjacent. Okay. And then the last but not the least, we have the cot theta. So cot theta is just entirely opposite of tan theta. Okay, so that means adjacent by opposite. So cot theta is adjacent by opposite. Okay, so totally there are six trigonometric ratios. One is sine, then cos, tan, then cosecant, secant, and cot. Okay, right? Then I want to give some note here. So first, sine theta is called the sine of angle theta. So when I say sine theta is sine n, okay. So you should never read it as sin theta. Please read it as sine theta only. So sine theta is called sine of angle theta. And then cos theta. So cos theta is cosine of angle theta. Then we have tan theta, which is tangent of angle theta. Then we have cosecant theta, which is nothing but cosecant of angle theta. Okay, so please read it as cosecant only. Okay, cosec, don't say cosec, better use cosecant. Okay, that will be good. And then secant theta. Secant theta is, see, sec theta, don't read it as sec theta. Instead, read it as secant theta. Full you pronounce it. Okay. And then so secant theta is nothing but secant of angle theta. And then finally, the cot theta. So cot theta, we have cotangent of angle theta is nothing but cot theta, right? Next thing I want to tell you is trigonometric ratio and the reciprocal. So now, as I told you, sine theta, the reciprocal of it is cosecant theta, cos theta, reciprocal is secant theta, tan theta, reciprocal is cot theta, cosecant theta, reciprocal is sine theta, secant theta, reciprocal is cos theta, and cot theta, reciprocal is tan theta. You need to remember this, okay, children? So very important concepts what I am discussing, okay? Now, how it is reciprocal, let us try to understand. So now we have cosecant theta into sin theta into cosecant theta, we get it as, see, sin theta, you know that it is opposite by hypotenuse, whereas cosecant theta, it is hypotenuse by opposite, which is equal to 1. Okay, so here opposite and opposite gets cancelled and hypotenuse gets cancelled. So let me show you the cancellation here. So opposite and opposite cancelling, hypotenuse and hypotenuse is cancelling. Okay. And then we have the next one. Similarly, we have cos theta into secant theta. Even this also, you will get it as 1. So here also show the cancellation. So adjacent gets cancelled. Hypotenuse get cancelled. You get it as 1. Okay. And then the last one, tan theta into cot theta. Even this also, wherein tan theta is nothing but opposite by adjacent, and cot theta, you know, it is adjacent by opposite. Both of them here, opposite cancels, adjacent cancels. So opposite gone, adjacent is gone. Right? Then we have another very important concept, that is relationship between sine theta, cos theta, and tan theta. Okay, so now we know that tan theta is what? Tan theta is opposite by adjacent, right children? So opposite by adjacent. Now what I do is I am going to divide both numerator and denominator by hypotenuse. I'm going to divide both numerator and denominator by hypotenuse. So that means to say, now here I write tan theta. Let me write this tan theta. And now here I'm going to write the fraction. So this tan theta, here we have I'm dividing this opposite by hypotenuse and adjacent also. I divide it by hypotenuse. Okay. Next thing. Now, what is opposite by hypotenuse? Let me show you the table for that. 1 minute. So opposite by hypotenuse is sine theta and adjacent by hypotenuse is cos theta. Let me show you the reference for this reference table. Okay. So now here we can see that sine theta is nothing but opposite by hypotenuse. So that's why it is sine theta. So the numerator becomes sine theta. And then we have adjacent by hypotenuse. So adjacent by hypotenuse is cos theta. Okay. So that means tan theta is nothing but sine theta by cos theta. Okay. So that is the relationship between the sine theta, cos theta, and tan theta. So tan theta is equal to sine theta by cos theta. Okay, children. Then in my next topic, I'm taking relationship between sine theta, cos theta, and cot theta. So here we know that cot theta is nothing but adjacent by opposite. So cot theta is adjacent by opposite. Okay, see here, cot theta is adjacent by opposite. Now we are going to do the division here also again. So now I divide both numerator and denominator by hypotenuse, that is h by p. Okay, hypotenuse. Now see what happens. So when we divide it, we get like this. Cot theta is equal to adjacent by hypotenuse, and here you see we get like this: adjacent by hypotenuse, then opposite by hypotenuse. We are dividing both numerator and denominator by this hypotenuse. Okay. So what is adjacent by hypotenuse? Adjacent by hypotenuse, we get it as nothing but adjacent by hypotenuse is nothing but cos theta, right? And then opposite by hypotenuse is nothing but sine theta. So that's why we write it as finally cot theta is equal to cos theta by sin theta. Okay. Now I want to give you some note, very important note, so that we are going to use it. So here we have this. The first one is sin theta whole square. Okay, sin theta whole square is not equal to sin square theta square. So you cannot apply the indices rule here. So when you do sin theta the whole square, it is not equal to sin square theta, sin square and theta square. We cannot write like that. And also at the same time, even it is also not equal to sin theta square. Okay, that is sin theta whole square is not equal to sin theta square. Okay, this is also not possible. So this means, now how do you write this actually then? So the sine theta whole square in fact is nothing but it is equal to sine square theta. So is nothing but sine square theta. This is the most important part aspect. Okay. Now that means, see what is this sine square? See what is it? It means, see, this means that sine square theta is nothing but sine theta into sine theta. So that's why we got a sine theta whole square. So sine square theta means sine theta into sine theta. It is multiplied twice. And then what about cos square theta? See? So similarly, cos square theta is cos theta into cos theta. Then we have tan square theta. So tan square theta is also tan theta into tan theta. Similarly, I have cosecant square theta, which is nothing but cosecant theta into cosecant theta. And then secant square theta, how do you write it? So it is secant theta into secant theta is nothing but secant square theta. And then cot square theta is nothing but cot theta into cot theta. Okay, right? And you can also, for example, we can write like this. See, what is sine cube theta? Sine cube theta means nothing but sine theta into sine theta into sine theta. So it is multiplied thrice, right? Then we come to the most important part. It is the identities. So in trigonometry, we have identities. Let us try to understand that. Okay. Now, for this, I'm going to consider a right angle triangle, ABC. Now, in this figure, we have triangle ABC, which is a right angle triangle in which angle B equals to 90 degree. Okay. Now here, angle C is called the angle of reference, angle of consideration or reference angle. So here, angle C is called the angle of consideration or the reference angle. And now the side opposite to angle C will be called as opposite. See, you can see this opposite side. So the side opposite to angle C is called the opposite side. And then the side adjacent to angle C is called the adjacent side. Okay, so in this figure you can see BC is the adjacent side. And then the side opposite to angle 90 degree is called the hypotenuse. Okay, right? Then using Pythagoras theorem. So I'm going to use Pythagoras theorem here. In this, we have AB square plus BC square is equal to AC square. Okay, so you have like this, AB square plus BC square is equal to AC square. So the opposite side square plus adjacent side square equals to hypotenuse side square. I can call it as equation 1. So let me call it as equation 1. Then what I do is I am going to divide this equation 1 throughout by 1. divide this equation 1 throughout by AC square. So that means here, let me take this equation. Okay. Now we are going to divide this by AC square like this. Okay. Similarly, BC square also I divide it by AC square. This one also. Okay. In my next step, okay. Now I can write this as AB square by AC square. I can write it as AB by AC the whole square. I can write AB by AC the whole square. Similarly, BC square by AC square, I can write it as BC by AC the whole square equals to AC square gets cancelled. As such, you get it as 1 on the right hand side. Okay, you can cancel those AC square and DC square. So I just cancel this. AC square and AC square got cancelled. Then what is this AB as such? So now here, if you look at this picture, let me show you a minute. Let me snip it. Now if you look at it, AB by AC, it is nothing but, so AB is what here? So AB is nothing but opposite and AC is the hypotenuse. Let us write that. So I write it as opposite by, so opposite by hypotenuse the whole square. Again, then I can write what is BC. Here BC is nothing but adjacent and AC is hypotenuse. So it's nothing but adjacent by hypotenuse, right? We can write that. So adjacent by hypotenuse the whole square, which is equal to 1. Next step, what I write is, it is nothing but sine theta the whole square, right? Plus adjacent by hypotenuse whole square is cos theta whole square. Plus cos theta whole square equals to 1, which is nothing but, or it's nothing but it's equal to. So then we can write sine square theta plus cos square theta. So sine theta whole square becomes sine square theta and cos theta whole square is cos square theta. It's equal to 1. Okay. So we get it as sine square theta plus cos square theta equals to 1. Okay. The next one. Again, I'm going to divide this equation 1 by AB square. So where is the AB equation 1? Here this is the equation 1. I'm going to this time, I'm going to divide it by AB square. Let us see what will happen in this case. So the first part we get like this, AB square by AB square, okay, and then BC square by AB square. Then the last part we get AC square by AB square. Or AB square here, AB square gets cancelled. Okay, I just cancel this AB square and AB square. That means to say now I get like this 1 plus BC by AB. BC square by AB square is BC by AB the whole square. So let us write that equals to AC square by AB square, which is nothing but AC by AB the whole square. Okay. Next part, I'm going to write it as 1 plus, what is BC? in fact, so BC is nothing but adjacent. And then we have this one, AB. What is AB value? So AB value is nothing but opposite, right? We can replace that. And similarly, AC also, we have AC is hypotenuse, AB is nothing but opposite. So let us write that. So I write it as adjacent by opposite to whole square equals to, and then we have hypotenuse by opposite the whole square. Next step, what I write is, so I'm going to write it as 1 plus adjacent by opposite is nothing but cot theta, that is cot square theta. So I write it as cot square theta, 1 plus cot square theta equals to, then hypotenuse by opposite, it is cosecant square theta. So it is cosecant square theta. This can be rewritten as, so I can rewrite it, the formula. So that means this identity, I can rewrite it as like this. So cosecant square theta equals 1 plus cot square theta. Okay, so done. Then I'm going to get another identity by dividing this equation 1 by BC square. So this time I'm going to divide it by BC square. Let us see what will happen. So I'm going to divide this one throughout by BC square. So this time I get like this. So AB by BC square. And then BC square by BC square. I get like this, which is equal to AC square by BC square. Okay. Then I can write this AB square by BC square. I can write it as AB by BC the whole square. So let us write that. So AB by BC whole square plus 1, because BC and BC gets cancelled, BC square and BC square gets cancelled. BC square getting cancelled. So I get it as AB square, AB by BC the whole square plus 1 equals 2. Then we get AC by BC the whole square. Okay. Or it is nothing but, I can write it as, so AB is nothing but opposite, and then BC. Here AB is nothing but opposite, BC is nothing but what? This is the adjacent, right? And then again here AC is AC is the hypotenuse and BC is the adjacent. So let us replace that. So opposite by adjacent the whole square, then plus 1 equals to AC by BC. So that is hypotenuse by adjacent the whole square. Or I can write it as opposite by adjacent is nothing but, by definition it is tan square theta. So let us write that plus 1 equals to, now hypotenuse by adjacent. So hypotenuse by adjacent, we are going to get it as what? It is secant square theta. Okay, so hypotenuse by adjacent will be secant square theta. So finally, what I can do here, so this means, so now I get like this. So finally, I get secant square theta is equal to 1 plus tan square theta. Okay, now what and all we learnt so far? Let us try to tell you. So here we learned about the formulas, important formulas we have. The sine square theta plus cos square theta is 1. Cosecant square theta is equal to 1 plus cos square theta. Secant square theta is equal to 1 plus tan square theta. Then tan theta is equal to sine theta by cos theta. And cot theta equals to cos theta by sine theta. Okay. So that's all for today's session. So we meet you in the next session with some more information. Okay, and please subscribe and share with your friends also. And hope you enjoyed the session. Take care. Bye.